I don't know because I'm getting the perfect view. Our subsequent, because where we are driving at, how do you derive these trigonometric functions? That's where we are driving at. Driving at trigonometrical functions. Having done this, again, go to trigonometrical Is it fine? We have taken note of this, right? We have taken, because you have to know all this. Where you'll be stuck, I will come in. All right. Another issue is last week we missed one class with you, right? Eh? You remember? We missed one. Yeah. So I think we'll find a time to replace that one. Let's look at radians, degrees, measures of angles. Radians and degrees, measures of angles. Radians and degrees, measure of angles. Radians and degrees, measure of angles. Radians and degrees, measure of angles. Right? In other words, when you look at radians and degrees of angles, this is to do with what is called trigonometric functions. So our area of discussions, the topic we are looking at is trigonometric functions. So this half of this, the last part of this semester, we are looking at trig. So we'll be looking at trigonometrical functions. Trigonometrical functions. All right? Trigonometrical functions. You know, these functions, these functions were firstly introduced by the Babylonians. The Babylonians, the Greeks, because they were good in doing this. In doing the trigonometrical functions, angles. In other ways, it helped them, especially, the Greeks, they were the first people to introduce what is called the Olympics Games. So this helped them a lot, especially in terms of basketball. So long time it was they developed this, the Greeks, So this way, this issue of trigonometric or trigonometrical, it is to do with the measure of triangles or the measure of triangles. So we'll be looking at how do we measure triangles, and again, what are their applications in terms of that. That's why we are looking at, we are starting our topic with radians, degree measures of angles. So by the end of this part of our lesson, I want you, one, to identify what is a unit circle. When we say what is a unit circle, you should be able to say, this is a unit circle. I want you to identify angle measure. You should be able to measure an angle. That this is an angle, you should be able to say, no, I can measure this angle. All right. Now, you can see now, we are looking at this being trigonometry. Now, again, the use of compass, protractors, and what are coming in. I don't know how you will sort out this issue, but the issue of compasses, they are coming in. And again, we'll look at conversion between degrees and radians. Degrees and radians are different, much as it is different your friend from your friend. So degrees and radians, they are again different. And again, we'll be looking at commonly encountered angles, which are the commonly encountered angles. So I think we'll be looking at that. Again, we'll be looking at an arc length and angular speed. Finally, we'll look at the area of a circular sector. We'll be looking at into these issues. All right. So this issue of trigonometry, it is to do with the height of an angle. Everything to do with an angle, we're looking at this. Now, let's look at, we'll be starting with our discussions by what a radian measure. We want to define what is a radian measure. So we are starting with defining a radian measure. Now let's go to the radians. Now we are starting with the radians. The radians. All right. We'll look at this issue of radians. Radians. We are looking at this, if you are making a relationship between an angle, and this angle is what is called a theta. When I look at this is a theta, is an angle, a theta. So we'll be looking at much this Greek letter, which is called a theta, be used as an angle at the center of a circle. So actually, if you are to measure radians, you are relating an angle within a circle. But now with any circle, you know, a circle has got a radius. So we'll be looking at, we'll be relating an angle in a circle of radius 1. The fact that we are saying it's of radius 1, that becomes what is called, a unity circle. So a unity circle, we are looking at this being a circle with the radius 1. So the angle, the measure of this angle in radius is what we are going to be interested with radius 1. For example, we are looking at this. We are looking at this is a circle here. How this is a circle here. And then a circle has a center. All right. A circle has a center. So I can draw something like this. I can draw something like this. If I am to measure from this point, this is a radius, to there. If I am to measure here, I discover that this is 1. Again, measure there to there. This again will be 1. Well, whatever, it's going to be 1. And this is our theta. Our angle, the one that we are interested in. In this context, we are looking at this is what is called, it's a circle with, it's what is called a unit circle. So this circle is a unit circle. It's a unit circle. A unit circle, a circle with radius 1. A circle with radius 1 all around. So radians, if you are to measure radians are abbreviated as rad. So in maths, we'll be looking at this as rad. So the moment I look at this word rad, just know that that is radius. So I can say, you can put it radius. So radians, they are rad. When you look at a radius, that is rad. Now this, the measure of a theta in a radius is the length of the portion of the circle subtended by a theta. Therefore, the length of the portion or the portion of a circle subtended by the theta, that one, if you are measuring it, it is the radians. So if you have to define the radians, we are looking at it as that portion that is being subtended by the theta. So subtended by the theta, that is this one. Well, this is the angle that is being subtended by this is the theta here, by this one, and this is our radians, which is abbreviated as this. So the radius, the rad, so it is that is the portion that is being subtended by that. All right, as long as provided that circle has the radius 1. In other words, that is a unit circle. So the length that is being subtended, the subtended portion of that circle of the units, that one is defined to be the radians measure. So we talk about the radian measure, we are looking at this. The radian, we're looking at the angle. But now the radian, the word radian is looking at that. This circle is what is called a unit circle. Why a unit circle? Because it has got the radius. It has got the radius is 1. The fact that the radius is 1, that becomes a unit circle. So definition of a radius there, I think it holds. Right? It holds. I think to make it that we can do it very fast, can you go get the 2 books from quickly? Open on page 462. Have you? Okay, now let's, right, if you look at, there are two, we have got two type of, if you look at that one there, we have got two type, we have got those two rays, all right, the angles, look at, we have got ray 1 and ray 2, right, ray 1 and ray 2. So look at those ones, those are the theta. So in general, an angle theta is by two rays, R1 and R2, is sharing the common origin, and that common origin is that one, which is the theta there, right, as shown. So we associate that sign of measuring of that as designating one array. Say R, we have got R1, so that R1 is one array, right? And we've got another R2 is another. But the initial one, if you look at the initial one, is the one that is, if you put R2 to be an initial, so you can look at that is what we are interested there. It is that angle, and that angle is the what is called the theta. So we have got the positive measure. But if the theta is defined by the clockwise go to the second one. The clockwise is the second one. All right. So we can say that that is a negative measure. So the clockwise is a negative measure. The anti-clockwise is a positive measure, according to, if you are to talk much about if you are counting the theta, if you are to define the theta based on those two rays. So if you look at the first one, there is a positive angle measure. Positive angle measure because you are going anti-clockwise, and there is a negative angle measure because you are going in the clockwise direction. So we have got those two. You have to take note of those two directions. So we have two directions there. Two directions, and these directions we have got clockwise direction, and we've got what is called anti-clockwise direction. Anti-clockwise direction. So the clockwise direction, something which is clockwise direction, that is a negative measure. It's a negative one. But the anti-clockwise, it is a positive measure. In other words, it's a positive angle measure. It's the positive angle measure is the anti-clockwise. So the first one is anti-clockwise. That is a positive angle measure. The second one is a clockwise. That is a negative angle measure. In other words, they are talking about R1 and R2. Those are just rays. So you can have a ray here, which is R1. All right, that's called there. Another ray here, which is R2. You can go something like this, R2. But the fact that this is a unit section, you can have these two here. So you can have this array and then this one. This is the center. If you are to count based on this is anti-clockwise. Therefore, this is what is called is a positive measure. But for the second one, it is when you have got R1, assuming that you have got R1, we've got the original one is this one, assuming that this is the original one. This is R1. All right. Another one comes like this. This is to be your R2. This angle here, this is what is called clockwise. So the fact that this is clockwise, this is a negative angle measure. This is a negative angle measure. Negative angle measure. All right. While this is a positive angle measure. Positive angle measure, and I've got a negative angle measure. All right. Now, in order to use our definitions of radians, if you want to use these definitions of radians to measure an angle defined by two rays, as it is in Fig 1 there, We place the vertex of the angle at the center of the unit circle. A unit circle is a circle with radius 1. All right, you know what a radius is? Or you do know radius, right? A radius from the center to the circumference of a circle, that is a radius. But a diameter, it measures from passing, but this one is a radius. So it's a radius 1. So further, we say the angle is standard position if its vertex location vertexes is located at the origin of the Cartesian plane. All right, and its initial size lies along the positive x-axis. So in this case, when you look at that one, where we have got the unit circle, on the, if you look at it on the graph, we can come up with the equation of x squared plus y squared is equal to 1. Let's go to this example. If we are to define what is x squared and y squared equals to 1, let's look at that example. So we are saying that the angle is in standard form or position. Any angle is in standard position if it takes this position, x squared plus y squared is equal to 1. So that is, when we look at that, where I've got x squared plus y squared equals to 1, that is what is called angle standard, the standard position of the angle. All right. So x squared plus y squared equals to 1. It's a unit circle. What does that mean? This means that it is a unit circle with radius 1. Example is this one. This is a standard position. An example is this. Assuming this is a radius. Assuming this is your circle here. The radius 1. Assume this is a circle with radius 1. That's what we are assuming. Assume that that is a circle with radius 1. So what does that mean? What it means there, look at this. Theta, this is x, and this is y. All right? That is x, and that is y. No. Now, if I am, this is yes. If I am to draw something like this, all right? This is the theta here. This is the theta. That is our theta. Now, if that is our theta there, if you look at this one, this is a standard. Here it is 1. And here it is 1. 1, 1. All right? Good. All right? Position. All right. Now, if you look at this one, it's the same as, if you draw that one, it's the same as something like this. All right. If you look at this one, it's the same. This is the light, and this is the light. And our angle we are interested in is this one. That is the angle that we are interested. So that is what we call the standard position. It is in standard position because if you look at this, all right, the radius is 1. The radius is 1. Everywhere the radius is 1. If, for example, assuming that our radius here, it is, let's put it here again to be 1. So it's the same as, this is 90 degrees here. It's 90 degrees. If we are to draw a line, if we are to connect a line from there to here, let's connect this line here. All right, you have 1, 1 here. All right, so Pythagoras theorem, assuming that you have got this, you have this Pythagoras theorem 1, 1. All right, say this square plus this square is equal to this square, right? So you say 1 squared plus, that's what you say, A, B, C. What you Pythagoras theorem says that AB squared plus BC squared is equal to AC squared. Right? You remember that? Okay, so here AB it is 1 squared, Pythagoras theorem, plus BC it is 1 squared is equal to AC squared. In other words, this and this one, it is 2, right? 2 is equal to AC squared. Therefore, if you want to find AC is equal to your square root, you are square rooting this side, right? The square root of this one is going to be like that. It's a standard, that one is a standard, it's a standard position of the angle. If, in other words, what we are doing there is the same as this. AB, it is our x. BC is our what? Oh, AB is our y. This and this one is our what? X. That's why they are saying y. They are saying x squared. So it's x squared plus y squared is equal to AC squared. All right. So here what they're saying is, even if you say 1 squared, if this one is, they're saying is x squared plus y squared equals to AC. But now in this context, if you look at this context, if we look at this one, we are going to come up that this one is going to be square root of 2. But generally, where we have a unit circle, where we have got a unit circle with radius 1, any circle with radius 1, it takes this format here, that x squared plus y squared is equal to 1, where 1 is the unit circle here. So x squared plus y squared, it gives us 1, and this is what is called a standard circle here, is a unit circle. We'll look at that and then we're going to define. Let's look at another issue here. How do we convert degrees to radians? Remember, we started with the radians. Radians are abbreviated as rad, and radians is an angle. Any angle from any standard unit circle is a radian. So radians are that identified theta, a theta. Now, how do we convert radians to degrees to radians? Degrees and radians are different. Let's look at what's the difference between a degree and a radian. And they want to convert. How do you convert degrees to radians? And how do we convert radians to degrees? Degrees and radians, they are different. Now, let's start. All right, let's look how do we convert degrees to radians. You need to know by now, you have to recall the formula for circumference. That is, circumference of a circle is equal to pi times diameter. I think the circumference of a circle. You need to know about the circumference. Circumference of a circle is equal to pi times diameter. In other words, the circumference is the perimeter of a circle. Perimeter, the distance around, is equal to pi times diameter. All right? But you can again identify what is your diameter. Diameter is, remember that diameter is equal to 2 times radius. You know that, right? So here is the same as perimeter of a circle can be defined as pi times 2 times radius, which is the same as 2 pi r. 2 pi r. If you look at this one, is the formula to find the perimeter or the distance around any object. So the perimeter is this. So how we calculate perimeter? It is 2 pi r. In other words, this perimeter 2 pi r is the same as the circumference c. So circumference is equal to 2 pi r, or you can say it is you can say it is pi times diameter. 2 pi r, or you can say pi times diameter. That's what we have been. So in that context then, we have to know, again, we have to understand that in any circular thing, anything to do with a circumference, something which is a circle, any circle comprises of 360 degrees. A circle comprises of what is called 360 degrees. All right? If you calculate all the angles, if I'm assuming that this is a circle, if I'm assuming that this is a circle here, if I calculate all the angles here at the center here, I add them together and I reach up to here, this gives me 360 degrees. So that gives me 360 degrees. All right. That is an angle whose terminal side and the initial side coincide. So they do coincide at 360 degrees. So the 360 is where everything you do coincide. They meet together at 360 degrees. But again, our intention, it is to measure radians. How do you measure radians? Remember, 360, these are degrees. So when you look at converting radians to degrees, how do you convert radians to degrees? So the 360 of which that is the angle within a unit circle. If you add the angle together, it is corresponding to 2 pi radians. So 360, it is 2 pi radians. Note that. Have to note that 360 is equal to 2 pi radians. 2 pi radians. We are starting it there. 2 pi radians is 360 degrees. So these are degrees. These are radians. 360 degrees is equal to 2 pi what? Radians. Clear? So 360 degrees is equal to 2 pi what? Radians. Isn't it? Then we can convert. What about 1 pi? How many degrees are there? One is a 1 pi radian. So to find, assume let's assume we want to find the value of pi radians, pi radi. So if 360 degrees is equal to pi rad, all right. So if let's find what will be pi rad. You divide by 2. You divide by what? 2. In other words, a pi rad will give us 100 and what? 80. So pi rad is 100 and what? 180. Because of that, you can find half pi rad. Half pi rad is 90, right? So 1/4 pi rad, you take 180 and divide by 4. All right? That's how we do it. So these are degrees, and these are marad. Therefore, what you have to take note is that 360. So I have to take note that 360 degrees is equal to 2 pi rad. You take note of this one. All right? You take note of that. You can convert, if you are given this one, you can convert. What about 1 degree? 1 degree be how many rad are there? 1 degree. You can find out what about 1 degree. All right? You can calculate. So you say 1 degree. It's going to be 1 over 360 multiplied by 2 pi rad, because we want to find it right? Or you can be taking this one. You can take that. That if 180 is equal to pi rad, what about 1 degree? You can work it like that, right? You can actually say, okay, if this is the case, then this is 100 what? 180. Therefore, 1 degree is equivalent to, is equal to what? Pi. Pi over what? 180 radian. Rad. Right? Oh, yeah, you can do it here. You can come here. All right? Find 1 degree. So 1 degree is equal to, it's going to be 1 over 100 and what? 80 times pi rad, right? Which is the same as pi over 180 rad, which is the same as that one. So, but generally, the principle here is that 360, 360 is what makes the circle. There are 2 pi rad. This pi is not the 3.14 that you have been looking at. It's not like that. These are radians. These are radians. The unit for radians, they are pi. So anything to do with radians, they are pi. They are quite different from that. So if you go to that, look at that. If it is 360, is equal to 2 pi. If it is 180, is equal to 1 pi. If it is 90, it is equal to pi over what? Over 2. All right? Let's go to the definition. Let's go to the definition. You can look at that definition. All right? If 180 is equal to pi rad, so we know that 1 degree is equal to pi over 180. Pi over 180 rad, right? And 180 over pi degree is 1 rad. Very good. What we are saying is, see, 1 degree is equal to pi over 100 and what? 80 rad. What about 1 rad? How many degrees will be there? How many degrees will be in one rad? 1 rad is equal to 1 over pi over 100 and what? 80 times 1 degrees. We want to find how many degrees will be there. All right? So this is 1 divided by pi over 100 and what? 80 times 1 in degrees. So this is 1 multiplied by 180 over pi degrees. All right? That's why when you multiply by 1, it gives you 180 over pi degrees. That's why. So 1 degree is pi over 180 rad. 1 rad is equal to 180 over pi. Is more that? Are we together? Good. Right? That example, it holds. Multiplying both sides of these equations by an arbitrary quantity of x. So x degree, you multiply by x to that. 1 degree, you multiply by 1 to that. What about x rad? You multiply that to the other side. Because if you want to find x rad, actually you want to find x rad, you multiply by x. You want to find 1 degree, you multiply by that. In particular, you have to note that generally you have to take note. 1 rad. You have to take note of this. That is 1 rad. Take note of this one. You have to take note that 1 rad is equivalent to 57.296 degrees. Take note. 1 rad is equivalent to what? 50 what? 51 rad is equal to 57 57.296. 1 rad is equal to this. You have to take note of that. So the moment that it is 1 rad, assuming that we are looking at 1 rad, it is 57. Let's calculate, find out whether what we are saying is true. All right. We actually said that 1 rad will be what? Let's where? Here? No. We actually 1 rad. Oh, this one, right? 1 rad is equal to, let's look at what is 1 rad, guys? 1 rad is equal to 360 divided by 2 pi, eh? Right? So 1 rad, right? Right? You divide by 360 divided by 2 pi, right? Sure. Which gives you 180 over pi, and this is 1 rad. Is that? Yes. That's what we have seen here. That 1 rad is this one. This is 1 rad. Yes. Are we together? I don't want you to get lost. Don't get lost. All right. 1 rad is this one. But we're saying that this rad is equivalent to 57.29. So which is the same as 1 rad is equal to 180 divided by pi. All right. You have calculators. Can you divide, find out what is 1 rad? Can you take 180 divided by pi? Pi the 22 over 7. So take 180 divided by 22 over 7. Let's find out whether this answer will come. Because the pi is 3.14. Something like that. 57.296. That's why they're saying that 1 rad is equal to 57. Why are they taking this one? Because a rad, it is 180 divided by what? Pi. So a rad, it is 180 divided by pi. That is 1 rad. 180 divided by that. So angle of 1 rad, it cuts off a bit less than 1/60th of a second. All right. A circle is let's make it to the nearest is 57, right? 57, right? But a circle is 300 and what? How many 57 will go into 360? 57 degrees. How many those ones are going to be? There are 6 of them. That's what they are talking about there. They are saying, in particular, take note that 1 rad is on an angle of 1 rad, it cuts off a bit less than 1/60. That's why 1/60 is coming in. All right? Because when you take 360 divided by, it gives you 6. All right? So an angle of 60 can cut off exactly 1/60. So because this is close to 60, so 360 divided by 60, it gives you 6. Right? So this is why here it had something like that. All right, let's proceed. How do we convert? Let's convert the following measures as express data to degrees, express 2 rad to degrees, negative express 270 in radians. There. So let's start with the first one. Let's go to the first one. Let's do it together. But I don't know whether it is making sense. A rad is a degree, but they are not the same. A rad is a measure. A degree is a measure. But if you numerate them, they will look be the same.
Put it on paper.
But a rad deals with because it is an angle that is being subtended somewhere. But when you measure these two, you can find the relationship between these two. Now let's discuss some of these issues here. I don't know whether it is making sense. Is it making sense? I should not expect it. Good. We don't mark like that. It's making sense.
Hey, please, attention. Hey, noise.
The first one, express pi over 3 to rad in degree. Express pi over 3 rad into degrees. How do you express it? Pi over 3 rad.
Briefly explain key elements of crisis management. How can you? You've dealt with a crisis. You have intervened in a crisis. Now, how are you going to manage that?
The first, say,
wait. Nikamasiya zinafu nimakapa chifuka.
2 pi rad. All right. Or you can say pi rad is equal to 180 degrees. Right? So you can say, either you can take, say, pi rad is equal to
this judge.
Pi rad is equal to what?
This one. That's what's
180.
180.
2 pi is 360, right? 3 pi, 4 pi, 8. 1 pi, 2 pi, 3 pi, 4 pi. You multiply by that, right? 5 pi, 6 pi, 8. All right. Half a pi is 90.
Did you read the instruction?
Quarter a pi. A pi, 8. But the standard one. Let's put this one to be the standard. This
is the standard. Just for the sake of giving you marks.
Which you can. That's
why I gave you this.
You can easily remember that. Hey, you can easily remember that the pi rad is equal to 180 degrees. Oh, 80 degrees here. Good. Then if pi rad is equal to 180 degrees, that's a standard one.
Okay.
Right? But the question is,
number 7.
Let's convert this pi over 3.
Let's
convert pi over 3 rad.
8.
How do you convert pi over 3 rad?
Oh. Number 4. Let's see. 10.
Pi over 3 divided by
23.
Pi multiplied by 180. Go.
2, 4.
This, it goes on top, this down. This is this one. This is this one. This is down. Multiplied by 180, right? So you are dividing here.
Where are you?
Pi over 3 multiplied by, what is this?
The last one is you, eh?
Divided by pi multiplied by 180. So it's going to be pi over 3 multiplied by 1 over pi. 8 multiplied by 1 and what?
Wait.
Wanted to find how many
number 1
will be there, right? So this and this one pi will cancel, right?
Question 4.
So we divide by this one to that one, right?
Question
180. This one gives you
number 3.
60.
Number 3.
60 degrees. It takes you to be 60 degrees. Clear?
5.
Good. You can talk 270 degrees to radians. How do you change 270 degrees to radians? You can do that, right? You can? Okay, very good. We should not waste time. I know you are mathematicians. You guys, you like. And again, you can do negative 2 rad to degrees. You can find that one, right?
5.
Yes.
Plus.
Good. Very good. Very good. Let me just read this. Before continuing, a note of terminology. Whether an angle is measured in degrees, this measure will appear followed by degrees symbol. And again, an angle measured in radians will appear with the abbreviation rad. The word rad is it goes like afterwards or more commonly with no notation at all. So it is a reflection of the importance of radians measures in mathematics. And if you no indication of the method of measurement appears, we are to assume the angle is measured. In other words, where you are looking at it, rad, sometimes we don't have the word rad, it means that is radians. So that is a radians. All right. Let's go to the other side. Let's go to the other side. All right.
Number 14. Number 14.
30 degrees. It is pi over 6. Right. Right? 45 degrees. It is pi over 4. Right. Is that? Go to the other side. Page 465. Go to 465.
Kodi mukuchiro nipangira zopanga ndawo yotuka klasi yakwani sono kusaina kumufuna usaina wadi yasala ya ndeno makosana mukuchiruka nzeru kwambiri.
All right. They are saying 30 degrees is pi over 6. Right? They are saying sometimes even if you don't write the rad at the end, it means that is the radian. You can say this. You can say 30. You can say 30 degrees. You can write 30 degrees is equal to pi over what?
Yes.
Pi over?
Yeah.
30 degrees? 30 degrees is equal to pi over 6. Right? Pi over 6. See, pi is equal to 108 degrees, right? Pi radians. Hey, you have forgotten. Pi radians is equal to 180. All right? 2 pi radians is equal to 360. Pi over 2 radians is equal to 90. You go on and on. Then what we are saying is sometimes instead of saying 2 pi radians, you can just say, you can do like this. You can say 2 pi is equal to 360 degrees. You can say pi is equal to 108. It means I can easily understand that is those are radians. Sometimes even if you don't write radians and you put like this one, it's the same. All right?
Do you know the...
If you say this is correct. If you say this is correct. All right? That's why they have looked at that one. Remember that the abscess of rotation following an angle means that the angle is in radians. Remember that the abscess of the notation at the end, it means that these are radians. Again. Remember that those are radians. Let's go to those two triangles. Let's look at those two triangles.
So my areas, key areas of crisis management. Which could be the key areas of crisis management research.
Recall, if the triangle connection comes from an application of what is called the Pythagoras theorem. Do you remember Pythagoras theorem? A squared plus y squared is equal to, all right?
Identify.
That's all right.
The root cause.
Recall that if A and B are length of two legs of right angle triangles, so A squared plus B squared is equal to C squared. You know that one. I cannot take much of my time. And recall that the sum of the angles of a triangle is 180 degrees, which is the same as
crisis
radians.
management. Who is supposed to manage the
So a triangle with one vertex, which is
service provider,
pi over 6, and the second vertex pi over 3, must have a right angle of the third vertex, similarly to that of the two vertex pi over 4.
Between you, ameno wagweredwa divuto.
In other words,
what they are supposed to manage the crisis. Who is in a crisis?
What they are saying is this.
Who has a problem? Now, between you who has a problem and somebody who is helping you, who is supposed to manage the crisis?
Look at this. Look at that.
Sometimes they can be both.
Okay?
They can be both.
What is this? 90.
50-50. Can you explain? Yeah, I like it. Who is
what will be the value
explain
it?
Give me a good example of a crisis.
Just degrees, right?
Can you give me a good example of a crisis? Poverty. Now you are poor. Now, if you are poor, somebody comes to tell you on how you are supposed to get out of that poverty.
Uncle Sam,
how are you going to manage that?
Is equal to 9.
So is the service provider, I mean,
and this gives you 180 increase.
Service user
for the triangle.
All
right. Now,
they tell me
45 degrees. So if you know that 180 degrees is equal to pi rad. What about 45 degrees? 45 degrees will be less, all right? So it's going to be 45 over 100 what? 80 times pi rad.
Yes, assessment here give you.
So 45 here, 1. 45 here, 4. So 45 degrees is equal to pi
alternatives
over 4 rad.
So who is supposed to explore alternatives? Work.
So 45 degrees is going to be pi over 4 rad. I'm converting this to rad.
Alternatives.
All right. Then what does that mean? Which means our triangle then, if I'm writing this triangle, is going to be something like this. This is the 90. This one will be, this will be pi over 4. And again, this one will be pi over.
Yes, this one I can take it.
Pi over 4, pi over 4.
Yeah, you know sometimes because human beings.
If assume that this is a
who is supposed to come up with a plan,
and the other side is pi over 3. Supposed to come up with assume that they want this is pi over 3
plan.
Find here. Find what is pi over 3. Pi over 3 is equal to 180 divided by 3. 60. Pi over 3 is 60, right? 60 degrees. So, which means this will be 60 degrees. Now, if it's pi over 3, this is 60 degrees. And this is 90, alright? What will be here?
4D.
So 90 degrees plus 60 degrees plus x.
Question
4D.
4D
is equal to 180. Alright? So x is equal to 180, take away 150, right? X is equal to 30 degrees. Let's convert 30 degrees to rad.
4D.
What is 30 degrees in rad? Pi over 30 degrees. Rad. Huh? Pi over 6. Therefore, this angle here is going to be 30 degrees, which is pi over 6. That's the drawing that I've drawn.
Question number 4.
Those two triangles.
4D.
All right.
Have you seen those ones? Right.
Okay.
4D6.
Now, suppose the triangle on the left in figure 3 has legs of length 1. That is 1. The Pythagoras theorem then it tells us, assuming that This one is 1.
Yeah, titanika in the follow. Usati mutanipeleke
1,
6. Yeah,
and this one
which
is
means
1. What have we said is the name of the circle with 1 radius?
C